Welcome to Peter Martin. Today, we want to explain differentiation using first principle. Differentiation from first principle. Okay, differentiation is a concept of calculus that tend to check the behavior of a function as a result of behavior of variable that is linked to it. Uh, Here from this example, we're having find the derivative of y equal x squared from first principle. Okay, we want to see how change in x affects y. If we were to use general method of differentiation, which had been explained in a previous video, so we say the y, the x, and what will it give us? The y dx will give us 2x. How? We multiply, there is a coefficient of x which is 1. 2 multiplied by 1 is 2 to give us 2x raised to power 2 minus 1. And 2 minus 1 is 1. So our answer is 2x. Let me bring back to our notice. The general formula is an x n minus 1. So our a stand for coefficient, n for the number of the power, multiplied by x raised to power n minus 1. So like here now, our a here, is going to be 1, as in our coefficient is going to be 1, multiplied by n. What is our n? 2, multiplied by our x raised to power n. What is our n? 2 minus 1 minus 1. So the y dx is equal to 1 multiplied 2, 2 times x, x. 2 minus 1 is 1. So we get our 2x. The y dx of x squared will give us 2x. But that is using the general method. But we are to use the principle of first principle. We are to use differentiation from first principle. So how do we go about that? Solution. If y equal to x squared, okay, y plus change in y, that is the y, is equal to x plus the s. What is the s? Change in s raised to power 2. Okay, so we are interested in change in y. Therefore, we have the y equal to x plus the x raised to power 2 minus y itself. Minus y itself. So, minus y itself. The y is now x plus the x minus y minus y. What is our y? Our y is x squared. Our y is x squared. So we need to expand this. And from knowledge of polynomial, x squared, x multiply the x will give us x ds multiplied by 2. Then we multiply this by itself. It's going to be the x squared minus x squared. If we collect like terms, x squared minus x squared plus 2x dx plus the x squared. So x squared crosses each other out. What do we have? We have 2x dx plus the x squared. So to get our dy dx, we divide both sides by x dx. divide both sides by dx. So we have dy divided by dx is equal to 2x divided by dx plus dx squared divided by dx. What do we have? 2x plus the x squared divided by dx give us dx. So dy dx equal to 2x plus dx. Find the limits of dy dx when the x approaches 0. Find the limit dy dx when the x approaches 0. So we are having 2x. What it means that anywhere you find the x, you represent with 0 plus 0. So our dy dx is equal to 2x. That is the answer we got when we use general method. Can we quickly do another example? The second example says, find the derivative of y equal x raised to power 3 from first principle. Now, if we are to find the y dx using the general formula, it's going to be the y dx, that is change in y over change in x, going to be 3x squared. That is 3 multiply coefficient 1, which is 3 multiply x, 3x. 3 minus 1 give us 2. So this will be our final answer. Let's go into first principle. So solution. If y equal x raised to power 3, then change in y, that is y plus the y, change in y equal x plus the x, which is change in s raised to power 3. Look at it. So as change in x affects change in y, we then have dy equal x plus the x raised to power 3 minus y. Dy equal x plus the x raised to power 3 minus y. What is our y? Our y is s cubed. Our y is s cubed. So what do we do next? The y, we need to expand this. From our knowledge of polynomial, okay, s is raised to power 3 plus the x raised to power 3. Then what do? You multiply s by the x, which is s ds, multiply it by 3. That will give you 3x ds, open brackets, x plus dx. You need to watch my previous video for you to understand this, because you just need to know it. Then minus x raised to power 3 minus x raised to power 3. Let's rearrange it. So we have x cubed minus s cubed, that is this x cubed minus this s cubed will give us the s raised to power 3. We can then expand this. It will give us 3x multiply x, x squared dx, plus 3x ds will give us 3x, the x squared, the x squared. So our dy 3 raised s raised to power 3 crosses out s raised to power 3 to leave with us 3x 3x squared dx plus 3x open bracket the s raised to power 2, we should not forget this, plus the s raised to power 3. So what do we do next? We divide both sides by x. Divide both sides by the x for us to get the y dx. So it's going to be the y divided by the x, which is equal to x squared dx divided by the x plus 3x the x squared divided by the x plus the s raised to power 3 divided by the x. So if we go by that, our dx, our dy dx is equal to s cross the s cross the s out. What do we have? X 3x squared plus the s crosses the s out. We have 3x dx plus the s crosses dx out. We have the x raised to power 2. Then what do we need to do now? We find the limits. Find the limits of dy dx when dx approaches 0. So what does that mean? It means wherever we find dx in this expression, we replace it with 0. So we have 3x squared plus 3 dx, that is 3x multiplies 0. We have dx squared here, so that is 0 squared. So our dy dx now will be equal to 3x squared plus 0 plus 0. So our final answer is 3x squared. What we got when we use general method. If you have gotten value from this video, give me likes. And if you are a newcomer, kindly subscribe to Petermatics so that each time I load a new video, you'll be among the first people that will watch it. Thank you. Keep solving mathematics. If you leave mathematics one day, it will leave you 4 days. Just develop love for mathematics and you will see your mark and grade going higher. Until we meet again, keep solving mathematics.